All right. So, in this example, we're looking for a specific value to end the loop, right? It's like we're watching. So, back in the old days, they used to have a watcher, right, to see if the enemy was coming. And they call it a sentinel. So that's why they call this a sentinel loop. You're expecting a value, and until you see that value, you stop. But I had to ask, let me ask you something. What happens if I do this? Will that program run? I just put a semicolon. Will that run?
Yes.
Yeah, it'll run.
But it won't do the same thing.
Yeah.
What I was gonna do?
Nothing.
It's gonna.
It's not gonna execute the next.
This is not. I'm sorry. What?
It's not gonna execute the next code, right?
Well, this is just
A new.
a block, right? So, what is the body of the loop?
The main.
If I put the, what would be the main?
The while. It'll just be back to press escape.
It would just be the next line, right?
What is the body of the loop right there?
The total equals total plus input.
The string.
Well, that's the,
Oh, wait, you're talking about the while.
what's the body of the while loop there? There's none, right? So what does the semicolon do? End of statement, right?
Yes.
Or end of instruction. So if I don't write anything there, my body is null basically. It's empty. Then you have a infinite loop. Because there's nothing that changes the condition. So you never put the semicolon there. What if I do this? Where is the body of the loop?
It's just the next line, right?
Mm-hmm.
Yeah.
So like the if statement. So if in the if statement, if we don't use curly brackets, then it's gonna use the next line, and it's the only line that's gonna be part of it. Same thing with the while. So guess what? Do we get an infinite loop there?
No.
Why not?
Because it's only one line.
So what's an infinite loop?
The same line over and over.
Well, it's the same. The loop is executed over and over infinitely, right? So let's say the user entered 10. Will that loop ever finish?
No.
So if you
Yeah.
try it, will that be true?
Yeah.
If I put 0, nothing happens. But if I enter other than 0, I enter 10. Guess what happens when I need 33 bits? an int is a 32-bit, right? So what happens when I need an extra bit? I'm gonna have I'm not gonna be able to fit that number because I kept adding 10. It's gonna take a while to get to that, to use all 32 bits, but eventually it'll get there. And the program's gonna crash because you have a memory overflow. You're having too many bits in one variable. So, although I just told you, at one point you're gonna make that mistake. You're gonna put a semicolon or forget the curly brackets, and then you're gonna watch this video and you're gonna say, nope, he told me. Alright, so I copy paste this code, right? And I hate copy pasting code. The reason is because after the total input, I do the as the input again. I didn't write it here. So I was able to go back to the question here. So what if let's erase some of these arrows. So what if I go this way? I go as the input, then I add, and then after I add, I ask the question. And if the answer was yes, or true, I'm gonna go back up here. Instead of going straight down. So I didn't have the as input after this because it was duplicated. So basically I wanna copy paste code. So what happens, looking at this diagram without looking at the programming side, what will happen if the user enters 10, for instance? I come here, I ask 10, I go here, right? 10 plus 0 is 10. Is the input different than 0? Yeah, go back. Ask the input, and they use 0. I go back here. Total was 10 and input was 0. So 0. Was the input different than 0? No. Goes out. It works. So how would you code that? So basically, I want to go back. I want to ask this question again. I do my code here, and at the end I ask if it was valid or if it's different than 0 or not. What happens if, to begin with, the user enters 0? As input 0, 0 plus 0 is 0. Is input different than 0? No? Get out. So this code always executes no matter what, right? At least one time. So if the user enters 0 to begin with, in that diagram, I execute the body of the loop first, and then I ask the question. So it's a post-test loop. And that saves me some extra coding. So basically, I want to ask here first, do the addition, and then, do the input first, do the addition, and then I'll ask the question. So, in other words, I don't need that. I only want to ask that once. But actually, I want to start here. Right? I want to start there. I don't need a pretest. So I want to do this here. This is my block. And at the end, I want to ask if the input was different than 0. And this time, because my while is at the end, not at the beginning, I do want my curly brackets. But how does it know where to match it, find the matching curly bracket? Well, we gotta use this keyword called do. So this is a pause test loop. And the body of the loop, because it's a top-down design, is executed at least once. So I ask the user, enter something. The user enters 10. Does the addition. Was 10 different than 0? Yep, go back to where the do is. Enter 0. 10 plus 0 is 0. 0 different than 0? No, continue down. So the first one we call a while loop, this is called a do while loop. Very technical. Questions, sir? Are you like, darn, I should have read the book. There's so many sources out there of textbooks and free textbooks and YouTube videos and whatever you need to understand this. So if you don't get it, when at the time of the exam, you can only blame you. Don't blame me. Alright, so when are you going to use the pre-test or post-test? Simple. If you need to execute the code at least once, do the post-test. If you want to not execute anything at all, you want to make sure that the condition is true before you execute it, then use the while loop. Because the while loop is the same as an if. It's a repetitive if. This is not. This is because it's executed. If I were to do this as a if or as a while, remember I had to copy paste this code. I had duplicated code. Question? All right, we can use, you know what a factorial is? You should do, right? So a factorial of a number, n, we use the exclamation, is the same as n times n minus 1 all the way to 1, right? Or it's the same as, you can do 1 plus all the way up times all the way to n. So if I have a number like, I guess I can erase this. So if I have factorial of 5, it's the same as, right? 1 times 2 times 3 times 4 times 5, right? Which is also the same as 5 times 4 times 3 times 2 times 1, right? Same thing. It's also the same as 5 times 4 factorial, right? And 4 factorial is 4 times 3 factorial, and then so this, the one, we call this our base case or default. And notice that this is the same as this, right? It's duplicating here, right? So, if we try to write a program to calculate factorials, the calculator doesn't do it, which is interesting. Let's write a program. The user has an input. So how would you write the diagram first? And then we'll write it in the computer or type it because it's easier for me now. So we start, right? We declare our variables. So I need the input and the answer, and they're both integers. And I need to initialize the answer to something, right? I'm going to initialize it to 1, because if I put 0, then every number multiplied by 0 is 0. And then you ask the user, right, as input, and then you're going to ask here, is the input greater or equal than my base case? 1. If the answer is yes, what shall I do? I need to multiply my answer times my input and then I gotta decrease the input by 1 until I get to 1. And then I go back and ask the same question again. If the answer is no, all I do is output the results. And then I stop the program. That's very straightforward, isn't it? And I don't have to ask the user enter another number. Once the user enters a number, I have the input, do I know how many times or iterations this is going to execute? So if the user enters 5, you know it's going to be 5 iterations, right? You go 5, 4, 3, 2, 1. Or you can do 1 through 5, whichever direction you want. That's a counting loop. Because I start with a number, I'm just incremented 1 or decreasing 1 or whatever your increment or decrement value is. So let's do this using a while loop. It's a while loop because my question is, my error goes back before the question, right? Not a do while loop because it's not going back to anywhere else. All right, let's see. If you open your computer, hopefully this will fit on the screen. For some reason it takes, oh, did I tell you, maybe it's Windows 10 what's doing it, but to me to write a video, make a video from my computer, the max it'll do is like 2 minutes. So I have to do that class that I did just in the computer. Gosh, it took me like 3 hours because I had to do it in 2-minute increments. And then sometimes I do 2 minutes and 1 second because I don't have the timer running. Then, oh, gotta start over again.
Is it just YouTube that's not allowing you to upload anything?
No, it's recording from my computer. I use Cam Studio. It's a free software. However, it probably needs an update. Let's change resolution here. Make sure everything fits on the screen. All right. So now. Oh, it's way up. All right, let's see if I can make this work. I wish I could zip tie it to the projector over there. That'll be interesting. I got workers' comp.
I can put it on top of the projector.
That will be too logical.
That's true, that's true.
All right, we're gonna work with what we got. All right, and so let's open Visual Studio. And I'm gonna call this factorial. It's a console application. Oh, wait a minute, this is C#. Let's do Visual. Yeah. So console application, I call it factorial. Next, uncheck the security checks. There it is. Hopefully you can see that. Yeah, you can. I just hope you can hear me from there. Alright, so the usual stuff, you gotta put your name, right? Author, date, today, and remarks, factorial. And I don't do this. And I'm going to collapse so I can fit more stuff in this screen. So that should work. So when we did this in the computer, if you do full size on YouTube, does it show? Can you read the code, bless you? Or you haven't seen it? I guess not. Alright. So I need 4 sections, right? My variable declaration, my user input, my calculations, and my output. Let's see. And I need 2 variables, right? One is my input, and the other was the answer. I think I had it. And the answer, we initialize it to 1. Guess what? We're gonna need another variable to use as a counter. So in a counter. Actually, I don't. Let's do it backwards, it'll work. So I ask the user for an input, printf, enter number greater than 0. And I use the scanf. It's a digit, and I need the address of the input. Right. What happens if the user is, I don't know, doesn't pay attention to the instructions, which is more than half of the time, and they enter a native number? How can you force the user to enter the correct number? We do a do. While their input less than 0 or equal than 0. So that way we know that by the time we get to the calculations, we got a positive number, right? We can test that part. Control F5. I don't know if you can see that from there. Sorry. So if I enter -5, keep asking me, even 0, till I enter a positive number. So that portion works. So you can use a loop or input validation. All right, assuming they finally got the message, now we gotta do calculation. So we have to determine the direction the loop is gonna go. If I had a counter, like I started doing, I could do an ascending loop, counting. But since I don't, I gotta do a descending. So I can do another loop, right? As long as the input is greater than 0. My calculation of the while my input is greater than 0. So no semicolon, and I got my curly brackets to determine the body of the loop. So the answer, whatever was there before, times the input, right? So the answer, I set the default value to 1. So right now is 1 times, let's say the user enter 5, so goes back on the answer. Now I gotta decrement the input. I can use a shortcut like that, right? So if I use plus plus, it'll increment this variable by 1, or if I use minus minus, decrements the variable by 1. Did I show you that before?
No.
Alright, so it's like saying input equals input minus 1. But since I type smart, not a lot, work smart, not hard. I'll show you, well, there's another shortcut too. Notice that in the equal sign I have the same variable, right? I'm just multiplying by input. So I can do a shortcut there too. Like that. You'll see that, I mean, I don't expect you to write it like that, but you'll see when you code that people will just use 2 symbols. What this is saying is
Same problem.
the same answer times input, put it back on answer. If this was a plus, it will be an addition, and that's just a shortcut. All right, let's do our output now. So, let's see this part. Let's see if it works first, and then I'll ask you a couple questions. So if I enter number 5, It says the factorial is equals 120, right? So if I use 6, 720. If I use 7, and keeps going up, right? What if I do this? So I want to say the number that I enter at factorial equals the answer. What will it print out if I enter 5? Well, there's two variables. What will be the values of those two variables? Before you run it, just tell me. What will be the first? What will be on the left side of the equal sign? What number will it print? What?
0.
It'll print out 0. Why? Because 0 is what made that condition false, right? Input was 1, it goes back up and tests, is 1 greater than 0? Yeah. And then the input is decremented to 0. And then goes up again, is 0 greater than 0? No. Exits the loop. So this value is whatever made the loop to exit. So if I enter 5, it says the factorial of 0 is 120, which is not true, right? So what I should do is print it before I exit start the loop. Let's try again. Oh, it works, right? 5 factorial equals 120. So what will be the factorial of 20? So the factorial of 20 is negative 21021327336. Why is that? It can be negative numbers, right? Something's goofy there. Any ideas?
Input minus minus.
So let's remember the first week of class. Remember the binary numbers, right? So let's open, let me show you in Excel. So I got 1 plus 1 there, and all the way to 20. And I'm gonna make this bigger. Can you see that there? Yeah. Alright. So this is equal to that. This is equal to this times that. So let's format these cells. I want to do number and the decimal. So those are the numbers that I'm supposed to have, right? But when I run this and I do factorial of 20, I get that weird number. I get negative 210 2132736. What if I run 19? What would that give me? Oh, that didn't give me a negative. Oh, that must be right. Not even close. And then you're like, darn it, my computer doesn't work. And then you go to Best Buy, pay the $200 to the Geek Squad, and they said you need a new motherboard. Now I get negatives again. Shoot, what's happening? Any ideas?
It's too large for any.
It's too large for an integer. Let's see when it works.
It's gonna work.
Well, why do I get some values? It's the question.
It just takes the first so many binary digits in.
Actually,
Not quite, because
it
of,
takes the last, not the first.
yeah,
So let's see.
yeah.
Look at this. Now I don't get negatives. However, it doesn't seem to increment. I should have done a loop asking if I want to add a new number.
Yeah.
Alright, so 1, 2, 7, 8, 9, 4, 5, 6, 0. Still not working. Gosh. Finally.
Woo, jackpot. Well,
Yeah. So you can write in the instructions. It only works from 1 to 12. What good is it, huh? So what's happening? Let's look at this number, 12. The last one that worked. And I'm going to open the calculator. And 12 is right there. And I'm going to use the programmer interface. So if I enter the number decimal, 479001600. So notice here, here's my binary, right? So my binary is like that. Preceded by 3 zeros, looks like. So 3 zeros, and then that number. That's the binary. Let's look at this number. That number was 6227020,800, right? If you look at here, the binary, let's convert this to binary here. This is my 33rd bit. I read one. That goes over. So if I take the first bit, that 1, and then just use 0111, 0011, whatever, is this number in binary. Take a look. So if I have that number, what was the other number? I say 193.205.3504. This is the exact same number. Let's look at this binary. Without the 0, without the 1 in front. Notice? Let's push this 1. There. So this is the same number. So binary wise, this number is greater because it's using a 64-bit. But we said an integer is 32-bit, so it stopped here. So these are negatives because how do we determine a number is negative? The leftmost bit is a 1. So if I convert this number, look, it used almost all 64 bits. So I bet if I use 21, I'm gonna need another 32 block. So I will need 96 bits, and I keep going up. So let's take a look. Ooh, that's really small. That's what I want this. So 32 bits. 2, 4. Alright, so that's 2, 4, 6, 8. That's a byte. And then 2, 4, 6, 8. Then 2, 4, 6, 8. 2 bytes. 2, 4, 6, 8. 2, 4, 6, 8. Another byte. And then 2, 4, 6, 8. 2, 4, 6, 8. So, if you notice here, 1, 2, 3, 4. Actually, is from here. Is 1 bit, 1 byte. I'm sorry. It's a 1 int. So from here to the right is 1 byte, 1 integer, 32 bit, and the leftmost bit is a 1. And then I use another byte, another integer. I'm missing 2 zeros here. That's why it's negative, because the leftmost bit in the 32-bit part is a 1. So, going back to our program, what can we do? For starters, we can change the integer to a long. Make a 64-bit. See what happens. So number 12 worked, right? But 13 didn't work. Let's see if it works now. Still didn't work. So you're scratching your head, and then let's put a breakpoint here. Like run it, and I use 13. And there's the breakpoint. So the answer here interesting. But the answer should be at 64-bit. So what is it 32-bit? And then you give up on C and you decided to change careers or do IT. It's easier to fix a printer than program because sometimes this doesn't work. If I do this, will it work? What is that? Put a breakpoint, see if it runs. It worked. What does that L mean?
Long.
Yeah. So, I don't know if this is gonna fix it. Still didn't fix it. It still wants to use a 32-bit. At that point, you'll be glad you're not in 1960 and you have to do it in C. You can use C++. And then you don't have this problem. Anyways, so we're talking about loops here anyways. Yes?
So, sorry, I understand that for a variable, instead of using integer to get the right answer from negative, all I have to do is change it to long.
Yeah, supposedly that works, but doesn't like it in Visual Studio. If you try it in Eclipse, it should work. So we got a little memory management problem. However, even if you change it to a long after you try 21, it's still not going to work. Because factorials are really large numbers. They grow up really quick. So if you do a graph of factorials, it almost looks like a vertical line. Anyways, so in here we have the prefix and the postfix loop. Questions? So you can take a quiz for loops now. You don't have any questions. It's either you didn't pay attention or you understand everything. So we're gonna talk. In C there's 4. In other languages there are 5 types of loops. And I think we're going to talk about the next loops next time. Because I think I tortured you enough for today. Yes?
So those all fall under the while loop category?
Say again?
Because we talked about busy loop, sentinel loop, do while loop, and counting loop, but those all fall under while loops.
So, well, this is a counting loop, isn't it?
Yeah, well, but other than that today, we had busy loops, which are always running, sentinel loops, which requires like a number every time from the user.
Well, remember in the if statement, we could declare a variable type boolean, and it's true or false. Just set that variable. The book doesn't talk about it, but you can call it a flag. When you save a file, have you ever right-click on the properties and it says size, and there are 2 sizes? You know why there are 2 sizes? And most of the time they don't match. That's because your file is fragmented. So the file has a pointer in between for the next segment of the file. Every time you save you append or modify a file, you just add in segments. It doesn't literally write the same spot or on the next spot if it's bigger, because that space might be used by another file. I mean, it could be months before you modify a file, especially if it's your resume, it could be years, right? So, although I don't quite know how big my file is. So when you work with files, sequential files, that means you start at the beginning and you go all the way to the end. We're going to talk about those later. When you work with sequential files, you will use a while loop. You start reading until you hit the end of the file. And I don't talk about this right now because I will have to explain to you files. And that is, after you understand arrays and pointers, then I'll explain to you files, and we're going to revisit the while loops. The next one that we're going to talk about next class is the for loop. And the for loop and the while loop, they're very similar, except that the for loop performs really much faster, quite faster than the while loop, because it's a counter. When you have counters, there's a register built in the CPU called a counter register. And I'll explain to you how that works next time. Yeah, the book distinguishes between Sentinel. There's another textbook that calls about flags. Pretty much what you need to know is you got a while loop and a do while loop. The do while loop executes at least once. You gotta make sure in the while loop we don't use the semicolons. In the do while we do at the end. That's about it. You gotta know your looping structure, that you have your condition, logical test, the body of the loop, and then you have an escape clause, something that will make my while loop exit. That's pretty much in a nutshell. What else does the book talk about? There are like 5-6 different type of loops, and they're all while loops. It's just what it's used for. Yes?
What chapter is this on in the book?
5.
5?
Well, you read it before coming, right? So you know. Yeah.
Could you have a counter inside the loop to see how many times it goes through? Just by another variable and then just having it display the number?
Well, class ends in what, 20 minutes? We're going to talk about, remember we had embedded if statements? We can have embedded loops too, so like an if statement. So what we'll do, remind me, we'll do is that we're going to do a stopwatch. You know, we're going to do the minutes and seconds, so we got 2, and we're going to see how many times that iteration goes. Or you can tell me, for instance, if I start a timer at 23 hours and 59 minutes, and if each tick decreases 1 minute, how many iterations will that be? It'll be 24 times 60, right? So we'll do that on next class. I encourage you to read the chapter. Questions? Yeah.
According to my analysis, it's better to count for 64 bits instead of 32.
Say what?
It's better to use longs instead of integers.
Most of the time you use integers. I mean, if you have a loop that's going to execute more than 4 billion times, maybe you need to rewrite it differently. All right. Be safe. Stay dry.
It's like a hot one. It's like it doesn't react.